Tesla has long been the gold standard in battery innovation, dominating the game with unmatched capacity and efficiency. But now, a bold new contender has arrived, turning Tesla's much-anticipated Cybercell into yesterday's news. This revolutionary battery isn't just more efficient, it packs more power, boasts a larger capacity, and redefines practical usability. Curious about what Tesla is up against? Let's dive into the groundbreaking battery tech that's shaking up the EV world and leaving Tesla in the dust. Enjoying the content? Don't forget to hit the subscribe button and turn on notifications so you never miss out on our latest updates. So who's QuantumScape, the genius behind this seismic shift? Meet QuantumScape, the Silicon Valley trailblazer that's giving Tesla a serious run for its money. Founded in 2010 by Jagdeep Singh, Tim Holm, and Fritz Prince, this company started as a scrappy little startup. That all changed in 2012 when Volkswagen, one of the world's biggest car manufacturers, took notice and teamed up with them, providing substantial funding. And it didn't stop there. Even Bill Gates saw the promise in QuantumScape and backed them with his own investment dollars. QuantumScape hit the headlines in 2020 when they revealed they were working on a game-changing battery that would leave conventional lithium-ion batteries in the dust. The buzz was immediate and global, with investors lining up to pour more money into the venture. But this raises a big question: what exactly is this revolutionary battery tech everyone's talking about? The answer: QuantumScape's cutting-edge solid-state batteries. Think of them as the next big leap in EV power. For years, solid-state batteries have been hailed as the future of electric vehicles, and for good reason. They share some similarities with traditional lithium-ion batteries, since they're lithium-based too, but with a groundbreaking twist. Instead of using liquid or gel electrolytes like their predecessors, solid-state batteries rely on solid electrolytes, often made of polymers or ceramics. While this might seem like a small tweak, it's a game-changer, delivering massive improvements in performance and utility. First, due to a much higher energy density, solid-state batteries have a way bigger capacity, which means that they'd allow for a much greater range but also being way lighter and more compact. So first off, thanks to a much higher energy density, solid-state batteries have a way bigger capacity. This basically means they'd allow for a much greater range, but at the same time, they're way lighter and more compact. This, in turn, will let the car be much more drivable because of a lower curb weight. And of course, it's also more efficient since it's not being overburdened by all that extra weight. Basically, what this means is that we're finally going to see range-efficient vehicles that aren't unnecessarily overpowered, which should also lead to a considerably lower price tag for electric vehicles in the future. What's even more interesting is that, despite being lighter, solid-state batteries actually allow for an even higher power output compared to regular lithium-ion batteries. So we'll be able to tap into even more power and create even faster electric vehicles. The cherry on top is the fact that solid-state batteries have a higher voltage tolerance, meaning that charging times will be much faster than regular lithium-ion batteries, which is, once again, one of the main drawbacks of electric vehicles over internal combustion engine cars. But the biggest reason why they're so much better than lithium-ion batteries is that they're also much more stable than them. The biggest concern that surrounds regular batteries is how easily combustible they are. You see, regular lithium-ion battery cells combine a flammable electrolyte with a significant amount of stored energy. Once the battery cell starts creating more heat than it can effectively disperse, the battery becomes very susceptible to spontaneous combustion. This process of producing excessive heat is known as thermal runaway, and it can be caused by short-circuiting, mechanical damage, and even overcharging or over-discharging. On the flip side, solid-state batteries are considerably more stable due to their not being able to eject the range of flammable or toxic gases, since they're completely solid and lack any kind of easily flammable liquid that can rapidly vaporize. What's incredibly interesting about solid-state batteries is that they existed as a concept for almost 2 whole centuries. Michael Faraday was the first person to discover solid electrolytes back in the early 1830s, which was the basis of all future development of solid-state ionics. However, solid-state batteries have been known for their short lifespan due to the rapid depletion of their solid electrolytes. However, even with this massive flaw, they were still potent enough to remain viable as an idea for the future. QuantumScape seems to have Tesla in a tight spot, with their strides in pioneering solid-state battery technology. It's only a matter of time before other manufacturers jump on the bandwagon, potentially leading to Tesla's Cybercell facing an early retirement. This raises the big question. Can Tesla catch up to QuantumScape? Let's start with the basics. Tesla is a giant in the industry, a well-oiled machine with immense production capabilities that go far beyond just research and development. Unlike QuantumScape, which is still classified as a startup focusing solely on battery R&D, Tesla has already proven itself with groundbreaking products that have reshaped the EV landscape. On top of that, Tesla has the resources and strategy to outmaneuver competition, including acquiring startups that could fast-track their quest for the ultimate EV battery. If QuantumScape proves its worth, there's nothing stopping Tesla from snapping it up. However, here's the catch. QuantumScape's work is still shrouded in mystery. Despite all the hype, they've yet to show any tangible results to back their lofty claims. This secrecy has led to skepticism, and in 2020 the company was even accused of fraud. Hedge fund Scorpion Capital labeled QuantumScape a pump-and-dump scheme after the startup secured over $1 billion in funding without delivering any concrete proof of its battery technology. The lack of a viable product has fueled doubts about their legitimacy. That said, change may be just around the corner. QuantumScape recently announced they're gearing up for mass production. Their factory is reportedly under construction and expected to be operational by 2025. The automotive world stands at a critical juncture where the future of battery technology could be completely rewritten. If everything goes according to QuantumScape's ambitious roadmap, we may soon witness a watershed moment that finally silences the skeptics and reveals whether these much-hyped solid-state batteries represent a genuine revolution in energy storage, or merely another case of overpromising in the notoriously challenging field of battery development. The implications of this revelation extend far beyond just one company's fortunes. They could reshape the entire electric vehicle landscape, potentially accelerating the global transition to sustainable transportation by several years. However, it's crucial to maintain perspective in this rapidly evolving technological race. We must be careful not to interpret any potential QuantumScape success as signaling Tesla's failure or diminished relevance in the EV revolution. The electric vehicle industry has grown into an expansive, multi-trillion-dollar ecosystem with room for multiple winners and technological approaches. While QuantumScape's solid-state technology shows remarkable promise, the sheer scale and diversity of the global automotive market make it highly improbable that any single company could completely dominate the battery technology space, especially considering the varied needs of different vehicle segments, from compact city cars to long-haul trucks to high-performance sports vehicles. Tesla, with its vast resources, proven manufacturing capabilities, and culture of relentless innovation, remains exceptionally well-positioned to respond to any technological breakthroughs from competitors. The company has repeatedly demonstrated its ability to adapt and evolve, whether through internal development or strategic acquisitions. Moreover, Tesla's vertically integrated approach and its massive investments in battery research through initiatives like its 4680 battery cells suggest the company is far from being left behind in the technology race. Even if QuantumScape achieves its goals, Tesla could potentially license the technology, acquire relevant patents, or develop alternative solutions that achieve similar performance through different means. Beyond just these two companies, nearly every major automaker and numerous battery specialists worldwide are pouring billions into next-generation battery research. Companies like Toyota, Samsung, Panasonic, and numerous Chinese battery manufacturers are all making significant strides in solid-state and other advanced battery technologies. This global competition ensures that no single player will monopolize the future of EV batteries, and that honestly, multiple technological solutions will likely coexist to serve different market needs. The true beneficiaries of this intense competition are ultimately the consumers and electric vehicle enthusiasts who stand to gain from these rapid technological advancements. As battery technologies improve, we can expect to see electric vehicles that offer, well, dramatically increased range that eliminates range anxiety once and for all. Plus, significantly faster charging times that actually rival refueling at gas stations. We'll also see improved safety with reduced fire risks and, longer lifespans and better durability for these batteries. As production scales up and technologies mature, we see, lower costs becoming a reality. This also means automakers get, greater design flexibility than ever before. We're also talking about a reduced environmental impact thanks to more sustainable materials and production methods coming into play. This competitive landscape is driving innovation at an unprecedented pace, with each new breakthrough pushing the entire industry forward. Whether it's QuantumScape's solid-state approach, Tesla's 4680 cells, or even some as-yet undiscovered technology, the end result will be better, more affordable, and more capable electric vehicles for everyone. The race to develop the ultimate EV battery isn't a zero-sum game where one company's gain means another's loss. It's actually a collective push toward a more sustainable transportation future that benefits all stakeholders.